So we have been looking at errors and exceptions. So let's digress a little bit and look at something quite different, because we will need it a little bit. There's something called a package. So what we saw is that Java organizes all the data in the program using this hierarchy of classes, right. So we have one public class per file, and we have private classes which may sit inside those files and so on. But Java also has an organizational unit called a package, right. And one reason for this is that you might of course have different classes which written in different contexts which have the same name. So we need to be able to distinguish between a class which has a name in this context from a class which has a name in that context. So this package is really a kind of way of organizing your names so that they don't overlap, right. So names don't overlap. So if I develop some code, then I can be sure that the names that I am using can be disambiguated from any names that you might use in your code by putting them into a package and saying that in my package I have this class, whereas in your package you have a different class. So with the class and the package name, these two things can be distinguished. So if I want to now import functions which are defined in other packages, I can just give the usual package name, right. So what this does is this imports all the functions which are in the package java.math.bigdecimal. So this is, as we will see, Java's typical terminology for packages, which is separated by dots, which indicates a hierarchy. So Java is in this case the kind of biggest, it's the kind of parent class of it's like a hierarchy of packages. So Java is bigger, then java.math is smaller, then bigdecimal is a particular package inside java.math. Now if I want all the classes in java.math, right, then I can import Java. Now technically speaking, this hierarchy in the name is also reflected in a hierarchy in how these files are stored on the disk, right. There is no direct reason why this should be the case, but this is how Java is typically organized. So if you have a Java system and you want to find out the files corresponding to bigdecimal, you would look at you locate the package directory for Java, and underneath that there will be a subdirectory or subfolder called math, and inside that there will be something called decimal. So if you want everything under math, all the packages under math, you can say java.math.star. Okay, but these are all specific packages. So there is no next level, right. After java.math, there is not java.math. Whatever, integer math or java.math or double math, which has a further level of packages. All the math packages are in this one thing under one level called java.math. Right. So when I say java.math.star, it says import all the individual packages at this level, but I cannot say import everything that Java has. Right, I cannot say java.star, which will say java.math.something, java.lang.something. So Java has a lot of these packages organized in a hierarchy. So under math you have all the math packages, under lang you have some language specific packages, right. So I cannot say java.star and get them all. So I can only use the star at the bottom level of this package hierarchy. So that's one important thing. So this is as far as the built-in packages, but as I said, the reason is to disambiguate. So when I write a package or you write a package, right, we should be able to tell each other's classes apart. So I should not be forced to use different names just because somebody else has used the same name. So we can create our own hierarchy of packages, and we use normally in Java a naming convention using dots, as I said, and which is kind of hierarchical, except the hierarchy is like our internet domain names, but they are backwards. Maybe it's more logical because this is how files are organized, right. If I have a directory system, then the root, and then the next one is the subdirectory of the root, and the next thing is the subdirectory of that. So as I go left to right in a file name, right, it's going more and more specific, whereas internet actually goes the other way, right. So .in indicates a domain that's in India, and .ac.in indicates an academic institution inside India, and then IITM.ac.in indicates all the domains which belong to IIT Madras, and so on. So then the Java name for this will be the other way around, right. So I start with in, then I go to AC, then I go to IITM and online degree. So this is just a naming convention, and this you will often see in Java. So when I now create a class and I want to put it in a specific package, right, then I use the package name as an extra header line inside my class definition. So this is my actual normal class description, right. I just add on top at the beginning of the class file the class.java file, I indicate the package name by saying package followed by the name of the package and a semicolon, right. So, this is an indicator to Java to put this particular class in that package, right. And if as we have been doing, right, there is no explicit package name given, then which package do they belong to? So, it turns out that everything that is sitting in the same directory or folder, if you prefer that word, belongs to the same package which is anonymous, right. So, anything which is not explicitly part of a package through a name given in the class file is actually belongs to the same package which is a kind of anonymous package, right. So, everything that, so if you write, that is why if you write a bunch of classes, we have no difficulty finding them, we do not import them because they are all sitting inside the same directory. So, they are implicitly available to us without saying import this directory, that class, and import this directory, that class. Okay. So, this brings us to another topic. So, we have seen these modifiers public and private, but in some examples and in various books, you will often see that people omit these modifiers. So, there is neither public nor private. So, what could it possibly mean? So, in Java, what this means is something which is visible within the package. So, that class is, if anything, is defined to be just a class or just a method, okay, or just an instance variable without saying public or private. It means that it is public within the class, within the package, right. So, remember that every class either belongs to an explicitly named package which is identified in the top of the Java file, or it belongs implicitly to this anonymous class which is shared by all the other classes in the same directory in which it sits. So, this default visibility of being public applies to methods and variables. Now, one could argue that this is natural with methods because you do want to use methods as a way of accessing variables rather than the variables themselves, but unfortunately Java does not have a mechanism to distinguish between this. So, if you leave one way could have been to say that you could only leave out public and private for methods, but you are forced to put in public and private for variables. But Java has chosen this option of allowing you to omit it for both, and so you can either omit it for variables or for methods or both, and wherever you omit it, it becomes public within a package. So, that means that if you actually write this these class definitions and you do not put a private, then other functions and other classes in the same directory will be able to update the values even though it is not explicitly public. So, although it is not directly related to packages, let us talk about one more thing that is possible, which is that now we have talked about the fact that when you have a class hierarchy and if something is private here, right, it is not visible here. So, we said for instance that if a manager is a special type of employee, an employee has some private information about say salaries, the manager cannot directly access that private field and modify it. It has to do it through the public interface that the employee class provides. Now, there may be situations where you trust the classes that extend to do it, but not all classes. So, you want something which is public within the hierarchy, but private outside the hierarchy. So, this is something called protected, right. So, protected is an attribute which says that it is public to any class, it's public to this class of course because everything is public within a class, but to any subclass. So, anything which explicitly extends this class can see this as public, anything which does not extend this class, it is private. So, when you go down this thing, then it turns out that protected, right. So, we have kind of, if you think of restrictedness, right. So, within a hierarchy, private is the most, if I declare something to be private, then nothing below me can see it, only I can see it. If I declare something public, not only everything below me, but everything all over any class can see it, and protected means it can only be seen in this. So, protected is limited public, right, it is public within the instance hierarchy. Now, the normal rule of Java is that when you extend something or when you redefine something or override something, you can reduce its visibility, you cannot expand it, right. So, you cannot change in general the visibility by making something that was private public, right. But it turns out that you are allowed to make something that is protected in a higher class public in your class, okay, and this will be used later on when we talk about cloning, which is a way of copying one object to another object. So, this is a small digression which is not directly about packages, but it is connected in a sense, because packages give us a visibility through this lack of a modifier, but we have now this new modifier called protected, which tells us about visibility within a instance hierarchy of a class.